We are taking R.D. Sharma Solution Class 12, Chapter 19. This is multiple choice questions for indefinite integrals. Now this question, it's a very straightforward question because we can get x from x square and we can formulate x raised 4 as x square also. That means x is the numerator, 4 can be written as 2 square and x raised 4 can be written as x square to the power 2. So when we put t equals to x square, dt by dx will be 2x. So this x dx will be equal to dt by 2. So when we integrate this, x dx is already we have got, that is dt by 2. You can have dt here, half can be kept outside, and this 2 square plus we have assumed x square as t, so it will be 2 square plus t square. So actually we are doing integration of dx by x square plus a square kind of integration. This will be 1 by a tan inverse x by a plus a constant of integration. A we will take as 2 and this t which is actually x square. So 1 by 2 tan inverse 1 by a tan inverse x by a, so 1 by 2 tan inverse t by 2 plus constant of integration. One more thing is required, which is the replacement of t. 1 by 2 into 1 by 2 is 1 by 4. Tan inverse x square, t is x square divided by 2 plus constant of integration. Okay, this is your final answer. Just match it. Which one is the correct one? So this is how this will be done. Now this question is a complicated question. Why complicated? Because in R.D. Sharma, the option is C. That means the third one is the correct. But what I am suggesting is it's not. I'll prove it. I will solve it and prove it that none of these is the correct answer. Let's do it now. When we have tan a plus b form, so we need to formulate the denominator into some form which is a plus b. So multiply numerator denominator by 1 by 2. So the denominator will be half into cos x plus root 3 by 2 because I have multiplied half with cos x plus root 3 sin x. So what is the benefit? You know that half is cos 60 degrees. So you can have cos pi by 3 in this place. Root 3 by 2 is sin pi by 3. So this will be cos x cos pi by 3. Then we have sin x sin pi by 3. So cos a cos b plus sin a sin b, if you remember the formula, let me write it here. It will be cos a minus b, cos x minus pi by 3. Now this is what we are talking about, the denominator. So this is 1 by cos x minus pi by 3. So we are going to integrate this. Half is also there which is in the numerator, remember. I'm just going to write it. Cos goes up, it will form sec x minus pi by 3. So integration of sec x is sec x log sec x plus tan x. Please remember this because this is going to come in the next question also. So log is basically log base e. So you can write it as ln. So sec x minus pi by 3. So take t equals to x minus pi by 3, dt by dx will be 1, dt will be equal to dx. So in place of dx, we can directly write dt. So this integration will be like this. Sec x minus pi by 3 is t, sec t. And dx dt are equal, so dt. So we have to integrate sec x or sec t, which I already told you. Just write the answer log modulus of sec t plus tan t. Please remember half is already there, alright, plus constant of integration. Now let's replace this t by x minus pi by 3. If you remember, half and half was multiplied numerator and denominator. So the denominator we have utilized, the numerator 1 comes here. So half log sec x minus pi by 3, which is t, plus 10 x minus pi by 3. And then modulus end with a constant of integration in the rear end. None of these is the correct answer. And the options which I am providing you, this is the whole idea. This is how you are going to solve it. So these are the references for you that you may apply here. Next one is x sec x square dx. Now x square can give you x. So let's take t equals to x square. Dt by dx will be what? It will be 2x. So dt by 2 will be equal to x dx. So when we integrate this, x dx, we will write it as dt by 2. So dt here, half here. Sec x square, what is t? X square, so sec t. Integration of sec t we just have done. I told you, log modulus of sec t plus tan t plus a constant of integration. Half remains here. Now t was taken as x square, so it will be half log modulus of sec x square, because I'm replacing t by x square. Sec x square plus tan x square plus constant of integration. This is your final result. Now how to do this? This is the reference for you. You can use it for your future reference. 1 by 5 plus 4 sin x dx equals to a tan inverse b tan x by 2 plus 4 by 3. That means we need to find out capital A and capital B. Capital C is just a constant of integration. We don't need to worry about it. So what are we going to do? Because on the right you can see it's tan. So we need to change the left so that tan appears or tan x by 2 appears. Because we know that sin x is equal to 2 tan x by 2 divided by 1 plus tan square x by 2. Because cos x is 1 minus cos square x by 2 by 1 minus tan square x by 2 by 1 plus tan square x by 2. So sin x can be replaced here. So the integration will be something like this. 1 by 5 plus 4, in place of sin x I am writing 2 tan x by 2 divided by 1 plus tan square x by 2. It's 1 plus tan square x by 2. So just there's a slight mistake, you can correct. So 1 plus tan square x by 2. Now this 1 plus tan square x by 2 will go up. You know already that. Denominator will be 5 into 1 plus tan square x by 2. That will give you 5 plus 5 tan square x by 2. Also 4 into 2 x by 2 will be 8 tan x by 2. So it will be a quadratic equation with tan square x by 2 and tan x by 2. So just take the LCM. That LCM will give you 1 plus tan square x by 2 in the denominator. That will go up. So I have already written that. When you solve this, this will be 5 tan square x by 2 plus 8 tan x by 2. Okay, this is dx. Now 1 plus tan square x by 2 is simply sec square x by 2. You already know that. If you take t equals to tan x by 2, you need to find out that dt by dx is simply sec square x by 2. And differentiation of x by 2 is half. So this dt by dx is half sec square x by 2 dx. So 1 plus tan square x by 2 dx. This 2 dt will be equal to 1 plus tan square x by 2, and this is dx. So 1 plus tan square x by 2 dx is twice of dt. So this integration will be like this. 2 dt in the numerator and denominator is 5 tan square x by 2. You have taken tan x by 2 as t. So 5t square plus 8t plus 5. Now let's take this 5 outside because we need to make the denominator as a perfect square. For that we need this 5 outside. So you can take 2 outside from here, 5 from here. Taking 5 outside, that means you have to divide 5t square plus 8t plus 5 divided by 5. All of these terms need to be divided by 5. So t square plus 8t by 5 plus 5 by 5 is 1. Now 8 by 5, you can divide it by 2, square it, add it, subtract. So what this will come to 2 4s are 8. 4 by 5 has to be added as a square and 4 by 5 has to be subtracted as a square. Now this 2 by 5 is always in the front. dt divided by a square plus b square plus 2ab, that is t plus 4 by 5 whole square, which is the first, second and fourth term. The second and fifth term, which is 1 minus 16 by 25, will be 25 minus 16 by 25, which is 9 by 25. You can write it as 3 by 5 whole square. Now t plus 4 by 5 can be taken just as x. So x square plus a square formula you can apply. So 2 by 5. 1 by a, which is 1 by 3 by 5. Tan inverse x by a, that is tan inverse t plus 4 by 5 divided by 3 by 5. Now plus a constant of integration, so we have already integrated. Now we are going to replace t by tan x by 2. Let's resolve this. 5 by 3 goes up, 5 gets cancelled, 2 by 3 only remains. Now let's do it this one also so that we can write it clearly. T plus 4 by 5 is 5t plus 4 by 5. This is 3 by 5. 5 gets cancelled. 5t plus 4 by 3, which is 5 tan x by 2 plus 4 by 3, like that. So this integration will become like this. T was taken as tan x by 2 if you remember. This I will be 2 by 3 tan inverse. Inside this we have 5 by 3 tan x by 2 plus 4 by 3. Now the penultimate step or the previous step was 2 by 3 tan inverse 5t plus 4 by 3 plus c, if you remember. So just write 5t by 3 plus 4 by 3. This will come. Replace t by tan x by 2. Now you have to equate it with a tan inverse b into tan x by 2 plus 4 by 3. So when you equate this, what are you going to get with a constant of integration? A is 2 by 3 here and b is 5 by 3. So a is 2 by 3, b is 5 by 3. That's your result. So how to do this? How to complete it? So this is a 4 or 5 marks question. So it's a very important question, right? All of this has to be done. Tan x by 2 formula you need to know, the perfect square, and finally 1 by a tan inverse x by. Now x to the power sin x by x plus cos x into log x dx. Now if you get one step correct, this question is very easy. That means if you can just think of taking x raised sin x equals to t, you will first understand, oh, I won't be able to differentiate or integrate it. That's a problem. For that, we'll take log on both the sides. When you take log on both the sides, this sin x, which is the power, will come in front. So So it will be sin x log x equals to log t. Basically, it's not log, it's log base e. You can write it as ln, or you can keep it like this one. So we have two terms, sin x log x on the left, log t on the right. So we will apply the differentiation both the sides, and we will use the product rule here. So sin x log x is 1 by x, then log x remains like that, sin x will be cos x. On the right, log t is 1 by t. Alright. Now this is dt by dx, because log t is 1 by t. Then you have to write dt by dx also, because log has t inside. You have to differentiate that also. Now do you see here? Sin x by x plus cos x log x is already there on the left. We have just done it. So take this dx on the left. Dt by t is simply this whole which I rounded. So the integration will become something like this. X raised sin x was already taken as t, if you remember. And this from here to here, it will be dt by t. So just write dt by t here. The tt gets cancelled. Only integration of dt has to be done, which is t plus c. Initially t was taken as x to the power sin x. X raised sin x. So this is your answer. You can just choose which one is the correct, which is the first one in this case. So this is how it will be done. Okay. Now this is a very tricky question. It's very easy but very tricky. You have to integrate this content with respect to log x. Now I am assuming log base ex as log x only. Alright. If I replace log x by x, the denominator of this question 1 plus log x will be 1 by 1 plus x square. So 1 by 1 plus x square has to be integrated with respect to x. So it is just integration of 1 by 1 plus x square dx. So this integration will be something like this. We are writing d in place of x. I'm writing log x, log base ex you can assume. And the denominator will be 1 plus log ex. So you can write it as log ex or log x square. Now log x, just for your understanding, let us take log x as some t. So you are actually integrating dt divided by 1 plus t square. You can have it as t or a p, just to understand that this is nothing more than integrating dt by 1 plus t square, which is integrating dx by 1 plus x square, which is tan inverse x. Direct result. 1 by 1 plus x square is tan inverse x. Write it as tan inverse t plus constant of integration. There is no differentiation here. Just replace t by log x right now. So this will be tan inverse in place of this t log x. Now write e also here, just to show the examiner, or just to choose this one. So this is your correct result. It's an easy question but a tricky question. Otherwise, you have done it already. Now cos 8x plus 1 divided by tan 2x minus cot 2x. So there are certain formulas which you are going to use. So there are going to be a lot of 2's coming. 2, 1, 2 like this. 2, 2. So you have to take care of that 2. Let me show you the formulas first. 1 plus cos 8x, that is 1 plus cos 2 theta or cos 2x is 2 cos square 2x. If you replace this 2x by 8x, the right one will become 2 cos square x, 8x by 2, which is 2 cos square 4x. So the numerator will be replaced like this. Coming to the denominator, tan 2x can be written as sin 2x divided by cos 2x. So we are going to replace tan 2x by sin 2x by cos 2x. And similarly, cot 2x will be written as cos 2x divided by sin 2x. Now, this tan 2x minus cot 2x, this can be written how? So this integration will be, as I told you, tan 2x will be what? Numerator can be replaced by 2 cos square 4x. I just showed you. 1 plus cos 8x has taken this shape. Denominator is sin 2x divided by cos 2x minus cos 2x divided by sin 2x. So when you see the denominator, it will be sin square 2x minus cos square 2x, and denominator will be sin 2x cos 2x. So this sin 2x cos 2x, this will go up. So let me write it here. Integration of 2 cos square 4x. This sin 2x 4 cos 2x goes up. So let me resolve it. If you multiply it by 2, divide by 2, it will be sin into 2 into 2x, that is sin 4x. So I am writing sin 4x here. But please remember, I multiplied it with 2. So you have to have a 2 in the denominator also. So 1, 2 is there. Alright. So there is a 2 cos square 4x. You can cancel those out. So there is no 2 just now. You know that cos square minus sin square is cos 2x. This is a formula known to you. So this sin square 2x minus cos square 2x, which is, you can just swap these two terms and have a negative outside. So what I'm saying is cos square 2x minus sin square 2x is cos 4x. But a negative will also come out. I'll just write that negative. 1 cos 4x and 1 cos 4x has been cancelled. But cos square x minus sin square x is cos 2x. But we have in the question sin square x minus cos square x. So I'm taking a negative. I'm writing it as cos square 2x minus sin square 2x. So this negative has come out. We can have a negative. Now this cos 4x and sin 4x, because I told you there is no 2. 1, 2 got cancelled. But when you have cos 4x and sin 4x, sin 8x will be 2 sin 4x cos 4x. So you ought to have a 2 in the numerator and denominator also. One numerator 2 will be utilized for sin 8x. One denominator 2 will remain. So all these 2 when combined and cancellation, only 1 by 2 will remain. That's very clear to you now. Now this integration of sin 8x has to be done. And there is a half, there is a 2 in the denominator also. Now this sin 8x will be integrated. It will simply what? It will be cos 8x. It will be negative cos 8x. Negative is already there. It has come as negative cos 8x. Then you have to differentiate 8x and divide it by 8. So negative gets cancelled. 8 to the 16. It will be 1 by 16 cos 8x plus constant of integration. But this question has one more part. This question is like this. Integration of this particular expression is equal to a cos 8x plus constant of integration. When you equate this, a cos 8x plus constant of integration, this a becomes equals to 1 by 16. So 1 by 16 is the correct answer when you equate these two. Alright. So just take care about all these 2's, and there is a negative also which will come. So whatever I've told you is given in front of you. You can just take care of this. There is a lot of integration being performed here, along with a lot of trigonometry which is utilized here, especially the cos 2x sin 2x formula, and then we have to equate it with a cos 8x. So a has come as 16 here. That's how we have 1 by 16, which is C as the answer. Integrals. Now sin to the power 8, sin raise 8 x minus cos raise 8x divided by 1 minus 2 sin square x cos square x. Now this is equal to the question I am just writing, a sin twice of x plus a constant of integration. So we need to find out the sin 2x. Anything which is in front of sin 2x or a coefficient of sin 2x, you can say, that will be your correct answer. Now this, always we know a square minus b square. Let's write this sin raise 8 as sin raise 4x square and cos raise 4x square. So now this has become a squared minus b squared. So a square minus b square is a minus b into a plus b. This you already know. We will write this. I'm just doing the numerator right now. So a square minus b square is a minus b into a plus b. So sin raise 4 plus cos raise 4x. And sin raise 4x minus cos raise 4x. We have not finished yet because we still have sin raise 4x minus cos raise 4x. So this can be written as sin square x whole square minus cos square x whole square. Again, using the formula, we will make it as a minus b into a plus b. In this case, a is sin square x, b is cos square x. So when you write this formula, this is for the sin raise 4x minus cos raise 4x. You know that sin square x plus cos square x is equal to 1, so we can just eliminate it. Now first is this one, second is this one. Now let's come to the denominator. We have sin square x plus cos square x equals to 1. So most of the time the students are tempted to write sin square x plus cos square x for 1. So numerator has been done. I am doing the denominator right now. Minus 2 sin square x cos square x. But the problem is that even if you do this, you are not going to get anything, because it is if you want to make a formula, it has to be a minus b whole square, that is a square plus b square minus 2ab. So you ought to have sin raise 4x here. Alright, so I hope that this kind of approach will not benefit us, because a square plus b square minus 2ab won't work here. So you ought to have sin square x plus cos square x whole square. So in place of 1, write sin square x plus cos square x whole square. Then you have minus 2 sin square x cos square x already. Now you can take a and b as sin square x and b square x respectively. A and b respectively. Now let's open this. A plus b whole square is a square plus b square plus 2ab. So sin raise 4x plus cos raise 4x plus 2 into sin square x cos square x will come. Then you have this minus 2 sin square x cos square x also. This will get cancelled. So then the denominator only sin raised 4x plus cos raised 4x will come. Now I am writing numerator divided by denominator as the ratio. So this numerator has come, which I am writing right now. Denominator we just did, and this has come as sin raised 4x plus cos raised 4x. Fortunately, the numerator and denominator has the same expression which you can cancel. So we just have to deal with sin square x minus cos square x. But incidentally, cos square x minus sin square x is cos 2x. Let me write it here. Cos 2x is cos square x minus sin square x. The only difference what you see here is the positions of the sin square x and cos square x that we can change after taking negative outside. So when we take negative outside, the numerator will become cos 2x because it will be cos square x minus sin square x. What is cos 2x integration? It will be, negative is already there. It will be sin 2x, then you have to differentiate 2x, 2 will come, it will go in the denominator. So this will be sin 2x divided by 2 with a negative plus constant of integration. So we have completed the integration. Let's equate it with the question. A sin 2x plus constant of integration. What you see here, minus 1 by 2 is equating to A, sin 2x is already there, C is already there. So from here, A is equal to negative half, which is the first option here. So this is how you're going to do this. It's a good question. And A equals to negative half is the correct answer in this case. Next one is x minus 1 into e raised minus x. So you have two different expressions and an integration. So we'll follow the integration rule here. The product integration rule, what does it mean? We'll apply the ILATE. ILATE is exponential is in the last. So we'll take x minus 1 as the first function, e raised minus x as the second function. So applying the formula, x minus 1 into e raised minus x dx. So we need to apply that formula. First will be x minus 1, second will be e raised minus x. So x minus 1 will come in front, integration of e raised minus x dx minus integration of e raised minus x dx will already be there. And then the differentiation of x minus 1 will be done. Then all these two components will be multiplied and then integration will be done again. You know that formula already. So we have x minus 1 here, e raised minus x. Integration of e raised minus x is e raised minus x. But minus x will be differentiated, negative 1 will come, that will go in the denominator. You can always keep it in the numerator also. d by dx of x minus 1 is 1. E raised minus x dx is already, we have done negative e raised minus x. So I can change this outside negative as positive. E raised minus x dx will retain here. So we need to integrate e raised minus x again. That will again give you negative e raised minus x. So we have minus x minus 1 e raised minus x plus a constant of integration with e raised minus x with minus 1 here. So just change the sign here. It's better to change the sign here. So what is the final result? You can take e raised minus x common and this minus x plus 1, because you multiply minus with x minus 1, it will be negative x plus 1, and then it will be a negative 1 also inside. 1 gets cancelled, only negative x will remain. So the final result will be negative x into e raised minus x plus a constant of integration. So let me write it here. You can just see now which one of these options are correct or which one is matching. So negative x into e raised minus x is matching here. And that's your final answer. So this question is a different question because this is a simple integration of two values, two expressions. Now 2 raised 1 by x square dx, and it is equated to k into 2 raised 1 by x plus constant of integration. So the integration on the left, right is the result of that one. That means we'll find out the result and we'll try to equate it with k into 2 raised 1 by x. Whatever is coming in front of 2 raised 1 by x, that will be our answer. So 1 by x can give you 1 by x square after differentiation. So when you put t equals to 1 by x and you happen to differentiate it, dt by dx will be equal to negative 1 by x square. That means this negative, if you bring on the left, negative dt will be dx by x square. So this dx by x square we got just now after putting t equals to 1 by x. So this integration whole will be like this, integration of 2 raised 1 by x. What is 2 raised 1 by x? 1 by x has been taken as t. So 2 raised t, negative dt, so negative I am taking outside, dt remains inside. So a raised x integration you know already. That is what we have to do here. A raised x divided by log a. Please remember, the log has base e in this case. So wherever you have x, put t. Wherever you have a, put 2. Now this formula can be changed and the values can be put here. So 2 raised t by log base e2 plus a constant of integration. Now t was taken as 1 by x, so negative 2 divided by raised to 1 by x, or negative 1 by log 2 Please remember base is e plus a constant of integration. Now you have to equate it on the right. If you see in the question, you need to equate it with k into 2 raised 1 by x plus constant of integration. So let me write this one here so that I can equate it directly. K equals k dot 2 raised 1 by x. C is there, 2 raised 1 by x is also there. So the k has become negative 1 by log base e2. So k has come as negative 1 by log 2, which is this one. Okay, now this is how you are going to do this. Well, MCQ doesn't want you to write and show, but this can come in any question, not only in MCQ. 1 by 1 plus 10x. So this question has already been done in integration. If you just revert back, go back and see the exercises from 1 to 32, you'll find this question already been done, but we'll do it here just to recall. 10x will be sin x by cos x. So 1 plus sin x by cos x will come. Now take this. I'm doing the denominator. 1 remains upstairs. So cos x plus sin x, denominator will be cos x, that will go up. So you can bring this or take this cos x and put it on the top. So this integration has become like this, integration of cos x divided by cos x plus sin x. Now what is this step we are going to do? We need to cancel it, of course. So just multiply 2 and 2. Multiply the numerator denominator by 2. This 2 cos x can be written as, see, I'm writing cos x and cos x. We ought to have a sin x here, so just add a sin x and then subtract a sin x. So this sin x plus cos x has come, which is actually the denominator, and cos x minus sin x has also come. So the integration will become like this. Half is already there. 2 cos x we have written like this, so I'm just writing that cos x plus sin x, and then second one will be, I'm just swapping these two terms, cos x minus sin x I'm writing. So cos x minus sin x in this case. In the denominator you have cos x plus sin x. So this you can separate this out in this step also. But rather than doing this, write this, and then in next step you can separate them out. So I'm just separating these two terms. Half remains like that. I'm going to multiply this half in the later part. Let's do the separation first. So first one part will be cos x plus sin x divided by cos x plus sin x. The second part will be cos x minus sin x divided by cos x plus sin x. So this cos x minus sin x divided by cos x plus sin x will come, and dx is always there. Okay, even if I skip dx, don't worry, because you know that dx is already there. Integration is with respect to something. So the integration, see, this gets cancelled, only 1 will come. So you are going to integrate dx only, which is only x plus. Now this cos x plus sin x can be taken as t. When you differentiate it, the numerator will come. We have done it already, so just to recall, t equals to cos x plus sin x. When you differentiate this dt by dx, cos x will be negative sin x will be cos x. So added with cos x minus sin x will come. So this numerator is actually, when you multiply it with dx, it will be simply dt, and the denominator will be t. So actually you are integrating dt by t, which will come as log t. You already know that. X plus log t will come with a base e, and this t will always come in the modulus. But t already know, we have know what we have taken, sin x plus cos x. So you can write directly here, x plus log sin x plus cos x plus constant of integration, multiply it with a half. So just multiply it. You don't have to multiply half with c. Just multiply half here. And now equate which one of these is correct answer. The last one is matching exactly what we have completed just now. Now this is how this will be dealt with, and you have to write, if it doesn't come in the MCQ, you have to write this. Okay, all this mathematics, all this putting equals to since, and therefore all this you have to do. Now this modulus x whole cube, I hope you have a very fair idea about modulus x. Modulus x is if x is greater than or equal to 0, that is x is a positive number, 0, 1, 2, 3, 99, 99,000 like that. So it will be x. But if it is less than 0, that is negative 2, negative 99, you have to put a negative to make it as a positive. That's why you have to have a negative x, because the modulus x will always give you the positive quadrant. The values will always be positive. So if x is less than 0, you ought to have a negative in front of that. That is why for x less than 0, it is negative x, because you have to have a positive value. You cannot have a negative value. So there will be two cases here. First case will be when x is greater than or equal to 0. So this modulus x cube, x will be x only. X is greater than or equal to 0. There is no negative involved. So it will be modulus x will be x only from here. So it will be x cube dx. So this will be x raised 4 by 4 plus constant of integration. It's a straightforward integration. In the second case, this will be x is less than 0. When x is less than 0, the modulus x will give you negative x, because x is less than 0. As I shown you earlier, you can consider like this: negative x into negative x into negative x. So it will be negative x cube. Negative you can take outside, and you just have to integrate x cube dx. So this will be x raised 4 divided by 4 with a negative sign here. So x is, the first case gives you a positive, same content, x raised 4 by 4, but it is positive in the first case, it is negative in the second case. So you are getting two values here, and these both values are being given in the MCQs also. The first one and the second one, they both are coming, the first and the third one. So you will say that it is none of these. So let me show it to you. This is how you're going to go about it. And if you want to write, it is not in the MCQ question, it comes in the actual question, then you have to write like this. So sec root x by root x, cos root x by root x, tan root by x by root x, cos sin root x by root x, all questions will be done like this, which I am showing you right now. In the previous exercise, that is the way VSAQ exercise, we have done 3 questions like this, one by one subsequently. So you just take t equals to root x. Oh, why I have written root t, I don't know, but it is actually t equals to root x. I'll just change it. Actually, differentiating anything with a root or root x or root t or root p, it will be 1 by this, say 1 by 2 came, and this will be 1 by twice of root x. This is differentiation. Let me change this t to x, it will create some confusion. So I'm changing all the t's to the x. I wouldn't have done it to begin with. So 1 by 2 root x has come. Now this dx by root x is already there. So dx can be brought on the right. So dx by root x is actually twice of dt. So we have 2 dt here. Dx by root x is already there in the question. So this integration will become like this. This integration will be cos root x we have taken as t. So cos t dx by root x is twice of dt. So 2 you can bring there, dt here. Cos t has a simple integration. You already know that sin t. 2 is already there, plus constant of integration root t, this t is root x, so to replace it now, 2 sin root x plus a constant of integration. Now this whole is the correct answer. Which one of this is the correct one? The D one, 2 sin root x plus c. So if it doesn't come in your this thing, you can means MCQ, you can solve it. Now this question, if you see, it seems something else, but if you know trigonometry well, 1 plus cot square x is cosec square x. This is a direct result. Sec square theta is 1 plus tan square theta. Cosec square theta is 1 plus cos square theta. Cot square theta. Cot, it is not cos, it is cot. So we'll use that. 1 plus cot square theta, you can write directly as cosec square theta. Erase x is outside, and the inside one we'll write like that. That 1 plus cot square theta, we'll write it as cosec square theta, and this cot theta will be negative. But I will not write it like this, because I can perceive or I can anticipate what is going to come. I will write this cot x first, because cosec square x should be placed first, cot x later. That means you ought to take a negative outside. The question will come as cosec square x minus cot x, but we have to have a cot x minus cosec square. You'll just see now. So I've taken a negative outside which goes beyond your integration sign. So just have to deal with this one inside one. Erase x, fx plus f dash x. If at all it comes like this, if it matches, erase x fx is the direct answer. If you take fx equals to cot x, you differentiate it, f dash x will be what? Minus cosec square x. That's what we wanted. Fx is cot x, f dash x is negative cosec square x. So as I told you, the direct result will be erase x into fx. So what is fx here? Minus cosec cot x. Fx was taken as cot x. So erase x into fx. The only difference here is negative is in front of integration, which you have to add here. Then you can see which one is the correct answer. Otherwise, erase x cot x will be may be the answer, but it is not. So negative erase x cot x is the correct answer, which is our second one. We have applied the formula here. Now we have sine raise 6 and cos raise 8. So if it would have been sine raise say 8, then we would have 10 raise 8. So we could have done something with that. So let's go along with that concept, because we have the tan in the answer. So what we will do here is, we'll take this sine raise 6x and cos raise 6x. And then we'll separate cos square. So this sine raise 6x divided by cos raise 6x. So we still have to multiply it with cos square x. So this whole sine by cos is what? It's tan x. So this sine by cos raise 6 will become tan x raise 6. This 1 by cos square x can be written as sec square x. and this is integration. So now if we take this tan x as t, so when we take t equals to tan x, the differentiation will give us sec square x directly. So dt by dx is sec square x. So dt will be sec square x dx. So in place of this sec square x dx, we can write dt. And since we have taken tan x as t, this becomes t raised 6. So this is the simplest integration we can have. It will be t raised 7 divided by 7 plus a constant of integration. Now since we have taken t equals to tan x, we need to replace it also. So this will be 10 raised 7x divided by 7 plus a constant of integration. So just match which one of these. The B seems to be the correct one. Now the next thing is how to do this, and if it would have not been in MCQ, this is the way you're going to go about. So whenever this kind of question will come, 1 by 7 plus 5 cos x or some a plus b sin x, this question needs tan x by 2 conversion, because in the options also, fortunately we can see that these are all have tan x by 2 in between. That means the first hint is to convert or change this cos x in terms of tan x by 2. So how do we do that? Cos x is 1 minus tan square x by 2 divided by 1 plus tan square x by 2. If you remember, sin x was 2 tan square x by 2 divided by 1 plus tan square x by 2. Similarly, cos x can be written in terms of tan x by 2. So we'll convert this cos x now in the tan x by 2 terms, and we will write it here. So this is the integration of 1 by 7 plus 5. In place of cos x now, we'll write 1 minus tan square x by 2 divided by 1 plus tan square x by 2. So in order to make you understand, because this tan square x by 2 will make the screen very clumsy, I'm just assigning some letter to it, not differentiating, just to show you that we are dealing with tan square x by 2. So 7 plus 5 into 1 minus p square by 1 plus p square, and this will remain only till we resolve it. So 7 into 1 plus p square plus 5 into 1 minus p square. This 1 plus p square will go upstairs. The denominator will be 7 into 7p square plus 5 minus 5p square. 7 plus 5 is 12 and 7 minus 5 is 2. So this will be 2p square plus 12. So we have 1 plus p square, that is tan x by 2 actually. So we'll replace this by tan x by 2. This was just for you to understand that what we are doing, because tan square x by 2, writing it again will make this screen a different one. I mean, I want it to be clear. So 1 plus tan square x by 2 comes in the numerator, divided by 2 into tan square x by 2 plus 12. The 1 plus tan square x by 2 is what? Sec square x by 2. It has a direct relation. Sec square x by 2 is 1 plus tan square x by 2, because x square x by 2 is 1 plus cot square x by 2, that you already know. So half I am taking outside, that is you have 2 plus 12. So if you take 2 out, only 6 will remain as the second term or second constant. So we have tan square x by 2 plus 6. Now we can write it in terms of square. So this will be tan square x by 2 plus 6. 6 you can write as root 6 whole square. Now you will ask, why have you done this? Because now we are reaching to a formula. When we take t equals to tan x by 2, dt by dx will be what? Sec square x by 2. Differentiation of x by 2 will give you half. So twice of dt will become sec square x by 2 dx. Because we already have this sec square x by 2 dx in the numerator. So I am taking dx on that side, 2 on the left hand side, and this 2 will fortunately get cancelled by 2 already. We have it in the denominator. So sec square x by 2 dx is dt, because 2 dt 2 already taken outside. Tan x by 2 taken as t plus root 6 whole square. So 2 cancelled. We can apply the formula of integration of dx divided by x square plus a square. So integration of 1 by x square plus a square, this is 1 by a tan inverse x by a. I think you have seen it a million times now. So 1 by root 6, in place of a I am taking root 6, in place of x we are taking t. So 1 by root 6 tan inverse t by root 6 plus constant of integration. The final thing is t was earlier taken as tan x by 2. So we are going to replace this t finally by tan x by 2. So 1 by root 6 tan inverse tan x by 2 divided by root 6 plus constant of integration, and this matches with the first one, the A one or the first one. Now this is how it is going to be solved. It's a good question. See, everything, like how does the marking works? First, cos x conversion to 1 minus tan square x by 2, 1 plus tan square x by 2. Then applying the integration. Then using this t equals to tan x by 2. All these 1, 1, 1 marks, you can imagine that this is how the marks of a question is evaluated. Next one is 1 by 1 minus cos x minus sin x. Now what you see in the answer it is either cot x by 2 or it is tan x by 2. That means you have to convert this cos x and sin x into tan x by 2 form. That is the default here. So 1 minus cos x minus sin x. In the previous question I told you, and these formula, that is cos x and sin x, was told also and was presented also to you. So just take the denominator first. Before integrating, we need to resolve it. So 1 minus cos x, you already know what to write. 1 minus tan square x by 2 divided by 1 plus tan square x by 2. This is your cos x. Now this formula you already know, that's why I'm not writing. We have written it a number of times. So I'm directly putting it. For sin x, you'll write 2 tan x by 2 divided by 1 plus tan square x by 2. No problem at all. So this is your cos x and this is your sin x. I am reiterating because this is going to come in your exam for sure. This kind of questions, like you have to convert cos x and sin x in terms of tan x by 2. So let's take the LCM now. 1 plus tan square x by 2. Now since the second and third term already have 1 plus tan square x by 2, so we don't have to worry about that. Only the first term will have 1 plus tan square x by 2. Other terms remains the same. So 1 plus tan square x by 2. Now multiply this negative, so negative 1 plus tan square x by 2 minus 2 tan x by 2. So what are we going to get? 1 will get cancelled. Tan square x by 2, tan square x by 2, there are 2 tan square x by 2, so it will be twice of tan square x by 2, and this negative 2 tan x by 2 remains like that. So I am cancelling it 1 and 1 and I am writing the final result. And please remember, it is the denominator. We are still talking about 1 minus cos x and minus sin x. We haven't yet started integrating. Now this is below 1. So let me write formally the integration. So this is 2 tan square x by 2. This is minus 2 tan x by 2. Now this 1 plus tan square x by 2 will be the denominator of the denominator. So denominator of the denominator is numerator. So this 1 plus tan square x by 2, I am writing it as sec square x by 2 because it is sec square x by 2. Now this 2 can be taken outside and we will directly deal with this tan square x by 2 minus tan x by 2 because we are going to make it as a quadratic equation followed by a perfect square. So this 2 I am taking outside. I am taking t equals to tan x by 2. So let's take t equals to tan x by 2 here. Now in the previous questions also we have done it. Dt by dx equals to sec square x by 2. X by 2 will give you half also. So this 2 dt will be equal to sec square x by 2 dx. So this sec square x by 2 dx, we can write it as 2 dt. Twice of dt, 2 comes outside. Tan square x by 2 is t square minus 2 t here. No, 2 we have already taken outside. So minus t. We will make it as a perfect square. So we just have to take the coefficient of t, which is 1, divided by 2, which will come as half. We'll square it. Whatever comes, we'll add it and subtract it. So plus half square minus half square will come. So this will give you, integration will be a square plus b square minus 2ab. So the first term will be t minus half whole square. And the second term will be minus 1 by 2 whole square. Or rather, yes, minus 1 by 2 whole square. So now we have a formula which we can apply. We have come to that juncture. So the integration of dx divided by x square minus a square. So let's do it now. X we will take it as t minus half and a we will take it as half as per this result. So x is t minus half, a is half. So this integration of dx divided by x square minus a square is 1 by 2a log x minus a divided by x plus a inside a modulus sign plus a constant of integration. So let's apply the formula. 1 by 2a. What was a? Just to recall you, x will take as t minus half and a will take as half. So 1 by 2a, 1 by 2 into 1 by 2 log modulus of x minus a, that is t minus half and t minus half plus half inside the modulus plus a constant of integration. 2 gets cancelled. Log will remain like this. T minus half is t minus half and half is 1 only. So it will be t minus 1 divided by half gets cancelled. It will be divided by 2 in the modulus sign plus a constant of integration. Now you can separate these two terms. See, you have a 1 here. You have to view or notice the answer also. Because in MCQ it is very important to get the answer. So t minus 1 by t is simply 1 minus 1 by t, which you have seen just now. So we can write it as log modulus of 1 minus 1 by t, and t is tan x by 2 we have earlier taken, plus constant of integration. Now this tan x by 2 will go upstairs and it will form cot x by 2. So log modulus of 1 minus cot x by 2 will come. Tan reversal is cot and cot reversal is tan. So what is the answer here? This is the C one, which I can see that it's closely match or exactly match with the answer we have achieved. Now this is how it will be done. It's a good question. It applies various different mathematical concepts. For example, this trigonometry we have used, integration result we have used. So all these will be combined to form a proper solution. X plus 3 divided by x plus 4 whole square e raise x. Wherever this e raise x comes, that means the examiner is trying to give you a question which has a direct result. I'll just write that, but before that let's simplify the first term. X plus 3 divided by x plus 4 whole square. So I'm making it as a 4. So I'm adding a 1 and subtracting a 1 in the numerator. So this x plus 4 will come, and x plus 4 will be coming in the both the terms we are going to handle. So I have added a 1 and subtract. I have added a 1 that will make it as x plus 4. The subtracted 1 will be a separate term. So we have x plus 4 and x plus 4 get cancelled. So only 1 by 1 x plus 4 will remain in the first term. The second term remains negative 1 by x plus 4 whole square. And this is the only simplification of the first part. Second part is e raise x here. Now if we match it with the direct result, which is your e raise x, inside that if we have a fx and then added with the f dash x, that is, the second term inside e raise x should be the differentiation of the first term. So if the first term, which is the 1 by x plus 4, we take and we differentiate it and we get negative 1 by x plus 4 whole square, then we are quite true with e raise x fx as the correct answer. So whatever fx you take, just multiply it with e raise x and that will be the answer. So fx is 1 by x plus 4, and you know that f dash x is negative x plus 4 whole square. You already know that, because 1 by x differentiation is what? Negative 1 by x square. That's a fact which we have known for long now. So fx and f dash x we got. So e raise x fx is simply 1 by x plus 4 plus a constant of integration. Now you match which one of this is the correct answer. Okay, so this is the first one, A, and this is how you're going to do this. I hope that this is quite easier for you. All right, there are 3 to 4 questions which we have done until now. We're on the 18th question, and those questions, they have used this expression, this result. Alright, this result is very important. If you don't understand this or don't know this, it will be difficult for you to solve. Sin x by 3 plus 4 cos square x. Now before I go ahead, what is the result? Means there are 4 options, and most of the options, they have a tan inverse also and they have a cos x also. That is, it is not required for us to change it, to convert it, because it already have a cos. Alright, so don't need to convert it to tan x by 2 form or any other form, because cos x will directly give us sin x, which is already upstairs. So this sin x which we are talking about in the numerator, 3 plus 4 cos square x in the denominator, if you simply take cos x as a t, so I'm taking t as cos x, and in differentiating it, dt by dx will give you minus sin x. We can exchange the positions of this negative and dx. So negative dt will become sin x ds. So the numerator we have got already. So this negative dt will represent sin x dx right now. 3 plus 4 cos square x. Cos x is t. So 3 plus 4t whole square has become. And now it's quite clear. You just divide everything by 4 in the denominator. You will get a formula, and that formula can be directly applied. I can see 1 by a tan inverse x by a formula right now. So negative 4 I'm taking out from the denominator. So when you take 4 outside, that means you are dividing every term by 4. So dt divided by this 3 by 4 can be written as root 3 by 2 whole square. 4 you can cancel out, this will be t square. So integration of dx by x square plus a square is simply 1 by a tan inverse x by a. You already know that. So a will take as root 3 by 2, x will take as t. So negative 1 by 4 is still there. I am applying the formula now, 1 by a, which is 1 by root 3 by 2, and tan inverse x by a, that is t by root 3 by 2. So let me write this t by root 3 by 2. T was taken as cos x, so I'll just replace this t by cos x in the next term, and I'll simplify this also. 4 divided by root 3 by 2 is what? 2 root 3. So negative 1 by root 3 will come as the coefficient, or as the first part, which is multiplied by tan inverse. What is t by root 3 by 2? 2 goes up, so it is 2t by root 3. T we have taken as cos x, so it will be 2 cos x by root 3. So let me write here 2 cos x by root 3 bracket close plus a constant of integration. Now just match it. That is the third one, the C one is the correct result which I can perceive. Okay, this is the reference or a solution for you. I hope you are comfortable with this question. The only thing is the kickstart of a mathematical question. Now this question also has the same approach as we have done in the previous question. Whenever we see this e raise x, we have to apply that result, which we already know. We also have this tan x by 2 and cot x by 2. That means we have to change this to some sort of this tan x by 2 or cot x by 2. So this 1 by 1 minus cos x I am separating, because 1 minus sin x can be taken like this, 1 by 1 minus cos x minus sin x divided by 1 minus cos x. Now this 1 minus cos 2 theta or 1 minus cos 2x is 2 sin square x by 2. That is, whichever angle is on the left, it will be half of that. So 1 minus cos x can be written as 2 sin square x by 2. Then we have this sin x. Sin x by 1 minus cos x, sin 2x is what? 2 sin x cos x. We can apply this here. Sin x is 2 sin x by 2 cos x by 2. So let's use this 2 sin x by 2 and cos x by 2 for sin x. In the denominator, again 1 minus cos x will remain same, 2 sin square x by 2 here. So what is the benefit? First, this half sin square x by 2 we can take upstairs, so it can be cos x square x by 2. It will be actually. This 2 you can cancel, 1 sin you can cancel. So sin x by 2 here in the numerator is vanished. Only cos x by 2 divided by sin x by 2 remains. So cos by sin is cot. So we write cot x by 2 here. Now we are approaching, because we want to integrate now. E raise x is already there. Now we are integrating. But one thing which I see here is, I want to match it with e raise x fx plus f dash x. For that we need fx first and then f dash x second. That's what is the default trivial things which we were doing earlier. The result will be e raise x fx after the integration. But fx cannot be taken as half cos x square x by 2. Fx will take as cot x by 2. So it has a negative outside. So we can take a negative all of it from both of them. We can take a negative outside. So the places can be swapped. So when you take a negative outside, it will be cot x by 2 minus half cos x square x by 2. So I am taking a negative outside, which I just explained you why I am doing this. I am taking a negative outside. Now we'll have a proper way of fx and f dash x. Because fx, if it is taken as cot x by 2, we definitely know that f dash x will be cos x square x by 2 half. Let's do it here also. Just to complete the question, fx equals to cot x by 2, and when you are going to differentiate it, it will give you negative cos x square x by 2 and differentiation of x by 2 will be half. This is half. So minus half cos x square x by 2, that is what f dash x means. Fx is cot x by 2. The direct result is e raise x fx plus constant of integration. E raise x remains here. Negative we have taken outside. Fx is cot x by 2 plus a constant of integration. That's your final result. Which one of this is correct? You can match it. So we have no half here. Negative cot x by 2, which is the second one. B is the correct result. Now this is how it will be done. This is the whole process, and which I explained you internally also. We have to apply this one. We have 2 divided by e raise x plus e raise negative x. So let me write it as 1 by e raise x, and it is square. So 2 divided by, we have e raise 2x plus 1 divided by e raise 2x. Now this is square. Please remember it's ex square. So when it goes up, it will be e raise x square. So the numerator became 2 raise e raise 2x 1 plus e raise 2x. And this is whole square. Now we have to integrate it. So 1 plus e raise 2x, if we take it as t, this dt by dx will be equal to e raise 2x, and then differentiation of 2x will be 2. So we have got 2 raise e raise 2x dx already in terms of dt. So numerator will replace it by dt. Denominator we have taken as 1 plus e raise 2x, so it will be t square. And integration of t square you already know. So t raise minus 2 plus 1 divided by negative 2 plus 1. It will be negative 1 by t. You already know that. So I am writing it after the integration, negative 1 by t plus a constant of integration. But what was t? If you remember, it is negative 1 by 1 plus e raised 2x plus constant of integration. But incidentally, we are not getting the answer here. So we have to change this answer in order to match the one of the 4 options. How can it be done? Because we need to match them, right? 1 by 1 plus e raised 2x is not the answer. divide numerator denominator by e raised x. So first one will become e raised negative x with a negative sign. This become e raised negative x, and this e raised x, e raised 2x will give you e raised x plus a constant of integration. Now is it matching? Just see, it's matching. Yes, it's matching with the first option. Okay, this one is the correct one. You can link it with A, or if MCQ comes, this is the answer. So this is the formal way of doing it. It's a tricky question, remember, because you have to divide it by e raised x in the last or at the conclusion point. Next one is e raised x 1 plus x divided by cos square x e raised x. So whenever we have e raised x, it's quite possible that we can apply that result, general result. Now we already know that x into e raised x, it gives you that e raised x 1 plus x, because we have the prior knowledge of differentiation. So when we take t equals to x into e raised x and you differentiate it, it will be x into e raised x plus e raised x, because we have applied the product rule. Now when you take this e raised x out, it will be e raised x plus 1. Dx can be brought on the left. So dt becomes the numerator here. This whole numerator has now transformed into dt only. So the integration in terms of t can be written as dt divided by cos square x e raised x was already taken as t. So it's simply cos square t. Now cos square t is simply sec square x t dt. Now sec square t, direct integration is 10 t, which is it, t should be inside the modulus. But t was taken as x e raised x, so write 10 x raised e x plus constant of integration. That is your final result. You can match it with the C one. C. So this is the process you are going to adopt, and this is quite awareness. If you are aware of the differentiation, you can do it easily. Now whenever we have the difference of the power, that is we have sin square x divided by cos raised 4x. Since 2 and 4 is there, you ought to have something to do with the difference in the power. So take the equal powers first and then separate out the remaining power. What does it mean? Sin square x is there. I am writing cos raised 4x as cos square x into cos square x. Now when you integrate this, sin square x by cos square x will be tan square x. 1 by cos square x will be sec square x. Integration dx. Now we are ready for it. But when you take t equals to 10x, sec square x will automatically come, because dt by dx is sec square x. You can take this dt equals to sec square x dx. So dt will come like this. So this integration will be d sec square x dx is dt. Tan square x is simply t square. So t cube by 3 will come with a plus a constant of integration. So t was tan x, so tan cube x divided by 3 plus a constant of integration. So you can match this. Third one is the correct answer. So this is quite easy for you. I hope you'll be able to do it by yourself. The primitive of the function fx equals to 1 minus 1 by x square a to the power x plus 1 by x when a is greater than 0 is. Alright. Now what is primitive? It's simply integration. What is the integral of this function? And from this question, we are self-aware that x plus 1 by x will give you what? We know that x plus 1 by x, if it is differentiated, 1 minus 1 by x square will be the result. So this fx, if it is taken as x plus 1 by x and we try to find out f dash x or d by dx, it will be 1 minus 1 by x square. So this integration of 1 minus 1 by x square, a to the power x plus 1 by x if we want to do, and a is greater than 0, x plus 1 by x if we take it as t, dt equals to 1 minus 1 by x square into dx. So this, if you have a dx and 1 minus 1 by x square here, it can be simply written as dt. A raised power x plus 1 by x was just taken as t. So a raised t dt is what we have to do. A raised x integration is very simple. A raised x divided by log a, the base has to be e plus a constant of integration. So a raised t divided by log e a plus constant of integration, e is the base. Only one thing is remaining, t has to be replaced by x plus 1 by x in the final result. A raised x plus 1 by x log a in the denominator. Match it and you'll see that there is no x here. Only the first one is the correct one. Alright, so this is your final result. So it's a good question, because those who are experienced with the differentiation will easily catch what we have to do here. Integration of 1 by x plus x log x. We can take this x outside. Just take x and you will see what will happen. So I am taking x out of this 1 plus log x only will remain. Integration of dx divided by x plus x into 1 plus log x. Now when you take this 1 plus log x as t. This dt by dx will be what? 1 will be 0, log x will be 1 by x. This dt will be equal to dx by x. Now dx by x is already in the question. This is already there. So what we can do? 1 by t dt and will be simply log modulus of t plus constant of integration. Now t was taken as 1 plus log x. So just replace this. 1 plus log x plus constant of integration. So the answer is the last one. D is the correct option. Log 1 plus log x. This one. So this question is quite straightforward. If you happen to take x from the denominator, it will be very easy for you. Now under root x by under root 1 minus x dx. Now all of these have sine inverse in the front. All the options. That means you have to do something with this sine inverse content. So x 1 minus x. We will use the trigonometric identities or the results. If you take root x equals to sine theta, x will be equal to sine square theta. When you differentiate this dx by d theta, if you differentiate both the sides, it will be 2 sine theta. Then the differentiation of sine theta will be cos theta. So it will be sine 2 theta. So dx has become sine 2 theta d theta. So what is the benefit? We'll see just now. X will be equal to sine square theta. Now integration will change like this. In place of x, we will write sine square theta. In the denominator, we will write 1 minus sine square theta. 1 minus sine square theta is cos square theta. Sine square theta by cos square theta is tan square theta. Under root tan square theta is just tan theta. That means if I write sine square theta in place of 1 minus cos square sine square theta, I am writing cos square theta. Under root sine square theta by cos theta can be written as sine theta by cos theta. Or you can write it as tan theta. But will this tan theta gives us something? I don't think, because this dx has to be utilized. So dx equals to sine 2 theta. I am writing sine 2 theta is 2 sine theta cos theta. Let's forget about that tan theta thing which I just uttered. So 2 sine square theta will come. Cos theta will get cancelled. 2 sine square theta will come. 2 sine square theta has a direct formula, integration of 1 minus cos theta. Alright. So 1 minus cos theta, let's separate them out. Integration of d theta minus integration of cos 2 theta. D theta. D theta integration will be theta minus cos 2 theta will be what? Sine 2 theta. Differentiation of 2 theta will be 2, so it has to be divided. So it's sine 2 theta divided by 2 plus a constant of integration. Now what is the final thing? We have to replace theta. We have introduced it by ourselves. So we have theta minus 2 sine theta cos theta in place of sine 2 theta. We write 2 sine theta cos theta. You can cancel these 2 out. So you have to write the answer like this. Theta minus sine theta cos theta plus a constant of integration. Now sine theta cos theta will be replaced like this. Because x is sine square theta, sine theta will be what? Root x. Cos theta will be under root 1 minus sine square theta. So under root 1 minus sine square theta is already x. So under root 1 minus x will be there. Sine square theta plus cos square theta is 1. That's why cos square theta can be written as, or cos theta can be written as under root 1 minus x. That's what we are going to use here. Theta minus sine theta under root in place of cos theta, I am writing under root 1 minus sine square theta plus constant of integration. Theta initially, because root x was taken as sine theta. So theta will be equal to sine inverse. Right, sine theta is root x. 1 minus sine square theta is under root 1 minus x. What is sine? What is theta? It's sine inverse root x plus constant of integration. So this is inside the bracket. It will be sine inverse root x minus root x into root 1 minus x. You can take root x common if you want. You don't want it. Let it be like this. Plus constant of integration. I just have to match it with any of the options which are provided. So which one is the correct one? Sine inverse under root x minus under root x minus x into 1 minus x. So this is how it will be done, and this is how the result will come. Alright, you have to match it with, because this question needs some effort. Now do you want me to do this, or it's clear to you? The result is e raise x fx. We have already discussed this and proven it while we were approaching to this questions. So even if you want to have a look, this is the description for you. Sin x plus cos x by under root 1 minus sin 2x. So we have done a question, this one in this exercise only, because we know that this denominator can be converted into something which relates to the numerator. I am writing this one as sin square theta plus cos square theta, or sin square x plus cos square x. Sin 2x can be written as 2 sin x cos x. This is simply sin x minus cos x whole square. This a square plus b square minus 2ab is a minus b whole square. So sin x minus cos x whole square under root of this. Now root of 2 will get cancelled, only sin x minus cos x will remain. So this integration will be Sin x plus cos x will remain in the numerator. Denominator is sin x minus cos x. And since sin x minus cos x gives you directly sin x plus cos x, if you take the differentiation of the denominator. So take this t, and please remember, whenever you get rid of the root, plus minus will come, because under root x square, it can be plus x square, it can be negative x square. So always remember to put plus and minus sign. Wherever I have left in the previous questions, please add it. Because in this question, we see that the answer comes in plus minus the last two options. So we have sin x minus cos x. I am differentiating it. Dt by dx is cos x plus sin x. Dt will be equal to cos x plus sin x dx, which is the numerator, of course. So plus minus sin x plus cos x dx is dt. Sin x minus cos x is t. Integration of this is simply log t. Plus minus remains as it is because we have removed an under root. Log modulus t plus constant of integration. T was taken as sin x minus cos x. Just replace it here. So it will be plus minus log sin x minus cos x plus constant of integration. And you can match it. It is the last option which you see here. Alright, it is matching exactly. So this is how this will be done. So this is the process. If you have to write it, then you write it like this. In this question, we have cos 2x minus 1 divided by cos 2x plus 1. So we need to make it somewhat in a way that we get some tan or cot. We know the formula of cos 2x. In terms of sine also we can write, in terms of cos also we can write with half of that angle. So cos 2x we are going to write like this: 1 minus 2 sine square x. There is one more way in which cos 2x can be written. You might be remembering and recalling all these things. It can be 2 cos square x minus 1. Let's put it here. In place of cos 2x, I am writing 1 minus 2 sine square x. So minus 1 is there. In this cos 2x, we can write 2 cos square x minus 1. So 2 cos square x minus 1, and then we have a plus 1 also. What do you get? 1 and 1 gets cancelled in numerator as well as the denominator. 2 also gets cancelled. Only negative sine square x by cos square x will remain. So I am taking this negative outside the integral. Sin square x by cos square x can be written as sin x by cos x whole square. Sin x by cos x is tan x. So we can write it as tan square x. And sec square theta is 1 plus tan square theta. In place of tan square theta, you can write it as sec square theta minus 1 or sec square x minus 1. That's what we are going to write here. And negative is here, so you can just multiply this negative with sec square minus 1, and you can swap the places of 1 and sec square. Now we can write 1 minus sec square x finally. Let's separate them out and integrate. Integration of dx and integration of sec square x dx. What is integration of dx? It's x. What is integration of sec square x? It's directly tan x. So plus a constant of integration. So x minus tan x plus c is your correct answer. You can match it. Now this is how it needs to be done, and I hope that you will be writing down those formulas or identities which I just wrote in front of this question. Cos 2x minus cos 2 theta divided by cos x minus cos theta. So we have just completed a question, and in that question we have used certain formula or results. So 2 cos square x minus 1, in place of cos 2x you can write minus cos 2 theta. For cos 2 theta you can write 2 cos square theta minus 1. Please remember, cos x is cos x, but cos theta is a constant value. So I'm just doing the numerator right now. I'm opening it to cos square x minus 1 minus 2 cos square theta plus 1. 1 you can wipe out. 2 you can cancel. 2 you can take outside because 1 got cancelled. Cos square theta minus cos square x remains. Cos square x minus cos square theta to be precise. A squared minus b square is a minus b into a plus b. Now I am coming to the integration. We have just resolved our numerator. So what we got out of numerator is 2 cos square x minus cos square theta. 2 I am taking outside. So we have cos square a square minus b square. Cos square x minus cos square theta is a minus b plus b. Cos x minus cos theta and cos x plus cos theta. Denominator is cos x minus cos theta. You can write it here. What is the benefit? You can cancel this cos x minus cos theta, numerator, denominator. Only twice of cos x plus cos theta will remain. So let's deal with this two later, and we have to integrate cos x and cos theta separately. I mentioned you cos x is cos x, but cos theta is just any other constant. So let me write it again. I equals to twice of integration of cos x plus cos theta. We will separate them out and integrate separately. Integration of cos x and integration of cos theta. Cos x integration is sin x, and cos theta is sin theta. Okay. Now this is a problem which most of the people will do. But the problem here is, can you identify the problem what I did just wrong? I was telling you from the beginning that cos theta is just a constant. Cos x is cos x with respect to dx. But the problem here is, or the mistake I deliberately committed is, cos theta you can take outside, integration of just dx will happen. So this sin x will remain like that because integration of cos x is sin x, but integration of cos theta, we are integrating with respect to dx. So when you are integrating with respect to dx, cos theta just simply acts as a constant. You can just take it out. Integration of dx will be x only. So you are going to eventually get x cos theta. What do you get? X cos theta. Now you can match it with the 4 results of 4 answers. And which one of this is matching? Just see. 2 sin x plus x cos theta, which is the first one, I guess. This one. The first one is your correct answer. So this is how you're going to perform this. Formula putting is equal for both of them. I'm not denying that. But the problem which will come to you is integration of cos theta. Sometimes people might just write it as cos theta. That's a problem. Now in this question, I have nowhere to start. Frankly speaking, I don't know how to start. But one thing caught my eye, and which is these 4 options. In these 4 options, 4 plus 1 by x square is common. So we have to do something so that we get 4 plus 1 by x square. So x raised 9 is the numerator. I am writing 4 plus 1 by x square, and we can get this after taking x to the power 12 as outside. Because if you see that it is 4 plus 1 by x square to the power 6, the denominator is something raised to the 6th power. So x raised 12 if you even multiply this inside, you will see that it will be, when it comes inside, it will be x square, because it is x square to the power 6. So x square will come inside. When you multiply x square inside, it will be 4x square plus 1. That is the whole idea. So when we take x square outside, it will be 4 plus 1 by x square, but x square cannot be taken outside because the power is 6. So x12 has to be taken out. So x raised 9 by x raised 12 will give you 1 by x cube. This 1 by x cube will go up. It will be x raised minus 3. So 1 by x cube, this is dx. 1 by x cube dx is the numerator. 4 plus 1 by x square is the denominator. And it is raised to the power of 6. Now just take t as 4 plus 1 by x square. When you take this dt by dx will be negative 1 by x cube. You know already 1 by x square how to differentiate it. But we have 1 by x cube dx in the numerator. Actually, it's not 1 by x square. I just mistook. X raised minus 2. So minus 2 divided by x cube. So there is a minus 2 which I missed. I'm so sorry for that. So, but we need 1 by x cube dx. For that, we want this negative 2 to be a goner, and that can be brought on the left. So negative dt by 2 is equal to dx by x cube. So negative 1 by x cube dx, now I'm writing or replacing it by negative dt by 2. So half negative dt by 2, I'm writing half outside. 4 plus x square was taken as t, so t raised 6. So you just have to integrate t raised 6 in the denominator. Take it upstairs, t raised minus 6. T raised minus 6 can be written as t raised minus 6 plus 1 divided by negative 6 plus 1. It will be t raised minus 5 by minus 5. This will be half minus 1 by 5 and denominator t raised 5. You have to bring it upstairs because the answer is like that. So what do you get? Negative 1 by 10, and this t raised minus 5, t was simply 4 plus 1 by x square. So we got the answer. I'm just writing it. Negative 1 by 10, t is 4 plus 1 by x square. I'm writing it in the denominator just now. And you have to bring it upstairs because the answer, 4 answers are matching like that. So 1 by 10, this goes up. 4 plus 1 by x square raised to the power negative 5 plus a constant of integration. Now match it. This is your correct result. So it was a good question. Alright, it wanted some effort. Now we have x cube divided by under root 1 plus x square. And this has to be equated to a into 1 plus x square raised 3 by 2 plus b under root 1 plus x square. A and b has to be computed. What is a and b? What is a and b? Once you integrate left, then anything which is coming on the right, we can equate it with a and b. So this x cube can be written as x square into x. Integration is already there. Denominator we have under root 1 plus x square. dx. 1 plus x square can be taken as t. When we take t equals to 1 plus x square, dt by dx will give you twice of x. That means dt by 2 has become x dx. Now x dx, we will just replace it by dt by 2. So this integration will be dt by 2 dt. Here we have 1 by 2. X square, because still there, we can change this t equals to 1 plus x square in terms of x square, it will be t minus 1. So we can write t minus 1 in place of x square. So t minus 1 dt, under root 1 plus x square is under root t. Now we can integrate it directly. We need to separate them out. So I am writing it again. Integration will be half, and first one will be t by under root t minus 1 by root t. So we'll separately integrate them. You know already we have done so many questions like this, but for the sake of completion we are going to do it just now. T by under root t, t raise 1 divided by t raise half, t raise 1, t raise negative half, power gets added, it will be t raise half. So half, t raise half you have to integrate for the first term. Second term is 1 by root t, it goes up, it will be t raise minus half. Half I am going to deal later. So it's simply 1 by t raise half, it goes up, t raise minus half has to be integrated. So t raise minus half will be, I'm just integrating these two with the power of x raise n, which is x raise n plus 1 divided by n plus 1. That is what we have to do. So t raise half plus 1 by half plus 1 first one, and t raise negative half plus 1 by negative half plus 1 second one. T raise 3 by 2 will come 3 by 2 in the denominator. T raise half will come, 1 minus half is half only. 1 minus half is again half in the denominator. Now we have a 2 here. So it will get cancelled with the 2 in the denominator, because denominator of the denominator is numerator only. So actually it's 2 by 3. I'm just changing t by this 1 plus x square now, because t was taken as 1 plus x square if you remember. So 1 plus x square raised 3 by 2 will come, which is actually now making sense on the right of the result which is given in the question. Under root 1 plus x square again here, under root half power is simply under root only. This half 2 goes up. Still I didn't tell you to multiply it by half. Actually I'm doing it right now. So 2 gets cancelled, 1 by 3 will remain. In the second term 2 gets cancelled, only 1 will remain. So I'm writing the final result because I have to match it with the right part of the question being given. So 1 by 3, 1 plus x square raised 3 by 2 minus the root 1 plus x square. Now let's match it with this. A here 1 plus x square 3 by 2. I'm just simply writing the right part of the question, and you will see what is matching. Plus b under root 1 plus x square. So 1 by 3 is simply a is 1 by 3, and b is simply negative 1. So b is a negative 1, and just match it. You are getting a proper answer here. A is 1 by 3, b is negative 1. And if you want to do it, it was a good question, and this is how it will be perform. Next one is x cube by x plus 1. Now just see the answer. There are 1, 2, 3, 4 terms. For that we need to go in for a different approach. What will be that different approach? X cube, I am adding 1 and subtracting 1. So I am adding 1 and subtracting 1. X plus 1 will remain in the denominator, but we are going to separate them out. How do we do that? X cube plus 1 divided by x plus 1. And just assume that it is 1 cube only. 1 by x plus 1. Now a cube plus b cube, you already know the formula. Alright, I'm just writing the formula directly because you are quite aware. I'm just changing this a cube plus x cube or x cube plus a cube. X will take it as x, a will take it as 1. It will be x plus 1, x square minus x plus 1. Denominator you have x plus 1 minus 1 by x plus 1. So just cancel these two. X plus 1 gets cancelled. Minus 1 by x plus 1 is here. So we have x cube. Let me separate them out and then we'll integrate. X square minus x plus 1 remains like that. This is with dx. So we are integrating x square first, then we are integrating negative x, then we are integrating simply 1, which is dx only. All dx are there, okay? I don't write dx. You already know that dx will remain 1 by x plus 1. Then x square will become what? X cube by 3. So we are now approaching the answer. X is x square by 2. Integration of dx will x only, and this will be 1 by x plus 1 log modulus of 1 plus x plus 1 plus a constant of integration. How easy it is now. So let's match it. The answer which we got and the question, it starts with an x. So this is how we match. All of them are matched, and that's your actual result. So this is how this has to be done. It seems to be a difficult question, but when you just add a 1 and subtract 1, it will be like cheese. 1 by x plus 2 and x square plus 1. So now this is very highly unlikely in my opinion that this is going to come, but still, since this question needs, we apply the partial fraction or partial fraction content. So we have 1 by x plus 2. Denominator is x square plus 1. So this will be a divided by x plus 2. X square plus 1 is also there. So bx plus c divided by x square plus 1. Now if you know how to do this, just skip this part, which I am just going to tell. A multiplied by x square plus 1 will be done first. Then bx plus c will be multiplied by x plus 2. This is your second one. X plus c, x plus 2. Denominator will come as x plus 2 into x square plus 1. And left you have 1 by x plus 2 and x square plus 1. Now you can just cancel these denominator because we don't need it anymore. It gets cancelled out. 1 will be equal to 1 equates to a. I'm multiplying now. Ax square plus a plus b into x bx square. Then twice of capital BX, then CX, then twice of C. Now let's match it. AX square plus BX square, you can take x square common. A plus B will come. Then we'll take the x term. 2BX plus CX. So 2B plus C, x will come. Then we have A plus 2C. 2C plus A. So 1 will be on the left. So A plus B, because there is no x square counterpart, A plus B will be 0. 2B plus C, there is no x counterpart, so it will be 0 again. 2C plus A has a constant on the left, which is 1. So A plus 2C is 1. Now when you solve it, I hope that you'll be able to do it. A will come as 1 by 5, B will come as negative 1 by 5, C has come as 2 by 5. We have done a 70 question exercise on that, so I hope you'll be able to do it. Now I am putting these values and then we'll integrate. A, B, C already found out. A was 1 by 5 divided by x plus 2. This second term, which is bx plus c, has come like this. Negative 1 by 5 x plus 2 by 5 divided by x square plus 1. So we are integrating it now with respect to dx. So I'll separate these into 3 different integration. 1 by 5 multiplied by integration of 1 by x plus 2 dx. These two means negative 1 by 5 x and x by x square plus 1. This is the second integration. Third one is twice of divided by 5 and integration 1 by x square plus 1. So 1 by 5. 1 by x plus 1 will be simply log x plus 2, which now is approaching the right part of the question. Negative 1 by 5 x by x square plus 1. X square plus 1, you can just take it as t. You will get a dt in the numerator. So that's it. That is how you can do. So it will be log only. Minus 1 by 10 log of modulus of x square plus 1. Last one is 2 by 5. Again, it will be 1 by 10 inverse x by a formula will use x as x and a as 1. So 2 by 5, 10 inverse x plus c. Now let's match it. Log x plus 2 here. Yes. 1 by 5 is there. So 1 by 5 is already there. We don't have to do anything. We have to find out a and b. Remember. Now we have negative 1 by 10 log x square plus 1. So log x square plus 1. This one. A is matching negative 1 by 10. So a is negative 1 by 10. Now 10 inverse has 2 by 5 in front of it. So b 10 inverse x. B is 2 by 5. B becomes 2 by 5. A and B we got. This is what you can match. And this is how, if you really want to do it by yourself, this is how you can approach this question and solve it. So this is all about this exercise. Thank you so much. Have a good one.